we are going to go over 7.5 operations with matrices. And just before we get started, I want to talk a little bit about a matrix, just so we understand what it is. A matrix can be denoted by a rectangular array of numbers, such as this right here. A matrix can be used to solve linear systems of equations, and there's also many other applications that this can be used for. In a matrix, for example, this one is a 3 by 3, and that's because it has 3 rows and 3 columns. So the first number tells us the number of rows, the second number tells us the number of columns, and this is called the order of the matrix. A matrix is denoted by a capital letter, such as this one with the letter A. These are called either entries or elements. And then only matrices of the same order can be added or subtracted. For example, these right here have the same order. They're both the same, 2 by 2. If they are of different order, such as this one, 2 by 3 or 2 by 2, then they can't be added or subtracted. So it's undefined. So this one will be undefined here. Alright, and now that we have a little bit of an introduction there, we can start looking at some examples. So we decided to skip 7.4. That's an introduction to matrices, but we can skip over that and just get into 7.5. So example 1 here has the addition of matrices, and if we add them, we can just add the corresponding entries, such as -1 and 1. So this one would be -1 plus 1. Then we'd add 2 and 3. 2 and 3, then 0 and -1. And then 1 and 2. So if you notice, the last ones we added were 0 and 1, and then 1 and 2. And then this would result in a matrix, and we'd get 0, 5, -1, and 3. So that would be our resulting matrix. For this next one, same idea, we just have a different order. This one's a 3 by 1, this one's a 3 by 1. So we're going to get 0, 0, 0. And the last one, letter C. If you notice, we have different orders right here. This one's a 2 by 3. This one's a 2 by 2. So we cannot add these two. So these are actually undefined. Okay, we cannot add them. Example 2. We want to use a graphing utility to find the sum of A and B. And if you don't have a graphing utility, you can go ahead and use, let me go ahead and pull that up right now. So let me go ahead and show you my screen here. So this is mathway.com, and you can use this if you don't have a graphing utility at home. We are going to need to use the graphing calculator, so we'll continue with that either in another video or on Monday, because we need to know how to use a graphing calculator to do this. So if you don't have a graphing calculator, we can use this website, and then you just click up here on pre-calculus, and then you select the matrix, and then you're gonna select, in this case, a 2 by 3. And let me go ahead and delete the first one. There we go. So we have the first one here, and notice that right here in our problem we have a 2 by 3, and we have decimals. So if we use our graphing calculator, it'll make it a little bit easier. So I'm gonna input those decimals here. So our decimals are 0.5, and if you press tab, it'll move you to the next one. 1.3, tab, negative 2.6, 1.1, 2.3, 3.4. And then if we click outside of the matrix and use our addition, we can add the other ones. So the other one is, we're gonna click over here, we're gonna choose a 2x3 again, and then we're gonna enter our elements. So negative 3.2, 4.8, 9.6, negative 4.5, and 3.2, negative 1.7 is the last one. Alright, and if we click answer, you see that it pulls it up right here, and it gives us negative 2.7, 6.1, 7, negative 3.4, and 5.5, and 1.7. So that is the correct answer. That's the resulting matrix we get. So this website, you can use it. You know, it has other functions. You can use it for trigonometry, geometry, basic math, and so forth. So that's one website that I found that can help you. Let me paste this up. Here we go. So here's what we had, and we're gonna need to also use the graphing calculator, as I had mentioned. If you do want to go on your graphing calculator right now and work with these, you would go to second matrix. You'll see that word in blue on the left side of your graphing calculator. Once you go into the feature, press the right arrow till you get to the edit, and once you press enter, then it'll allow you to enter the matrix, in this case a 2x3, and then your entries. Every time you input an entry, press enter to move on to the next one. And then once you've entered all the entries for the first matrix, go back to second matrix, and it'll allow you to input the one for B. So you'll see letters you'll see a list of letters A, B, C, and so forth. You can just choose, go back to edit, then choose B, press enter, and then you can start entering the entries for this one. To calculate these two, the addition of them, go to quit. That'll send you to your main screen, and or you can just go back to matrix, but don't go to edit this time. Just choose the letter. So you're gonna choose A, and then it should display it on your main screen. Then you're gonna press the addition symbol, and then you're gonna go to matrix, choose B, and that'll display it on your main screen. And then you hit enter for your calculator to add these. So that's what you could do right now if you wanted to use a graphing calculator. But if you don't, it's okay. We'll go over it again in another video, or we'll go over it on Monday as far as using graphing calculator. We'll move on to example 3. So example 3 right here is scalar multiplication and matrix subtraction. So a scalar is just an integer that when working with matrices we call a scalar. So for example here, the 3 would be a scalar because it's going to be multiplied times this matrix right here. So for example, letter A, they're asking us to multiply 3 times A. So 3 is a scalar, so we're going to just multiply 3 times each of the entries. So 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, and so forth. So this is going to result in 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, and so forth. You get the idea. So this would be, just going to finish listing them all here, just so we can see what we're doing. So we're going to have that right there. And then we just go ahead and simplify this or evaluate them and rewrite it. So we get 6, 6, 12, And there it is. So that's our resulting matrix. For letter B, they want us to negate the matrix B. So another way to think about this is that we can multiply -1 times matrix B. So if you are noticing, it's very similar to what we've done with integers in the past, and a lot of the operations we're gonna do here with matrices are similar to what we do in regular algebra. So this one, we're just gonna say -1, and up here you see matrix B, so we're gonna multiply -1 times each of these entries. So -1 times 2 times 0 times 0, and then -1 times, we have 1, -1 times 4, -4, -1 times 3, and -1 times -1, 3, and -1 times 2. Like putting parentheses around some parts but not others. And then we end up getting -2, 0, 0, -1, 4, -3, 1, -3, and -2. So there's our matrix B when we negate it or multiply -1 times this matrix. So that helps us solve this one. So here they want us to multiply matrix A times 3 and then subtract matrix B. So since we already found the solutions for each of those up here, we can just rewrite them down here. So this would be written as 6, 12, -9, 0, -3, 6, 3, 6. So notice that what I wrote right here is what we got for multiplying 3 times A. And now since I'm going to add, since I already negated matrix B, then this is the matrix B times -1, so I can just add this to this one and it'd be the same thing as 3A minus B. So I'm going to have -2, 0, 0, -1, 4, -3, 1, -3, -2. And then we just add those two together. So we're going to add each entry that corresponds to the other matrix's entry. So we're going to get 4, 6, 12, -10, 4, -6, and then 7, 0, and 4. And that's what we get when we get a resulting matrix.